In this problem, we're asked to find the domain for the composite function f of g of x. We need to keep in mind that we can only plug in values 2 to 6 into the equation for g of x, and then whatever we get out for g of x, we're going to plug into f of x, so g of x needs to stay between 1 and 7. So we're going to figure out what x values will make sure that we're okay and inside the domain for g of x and stay inside the domain for f of x. To do that, we're going to set the equation g of x in between 1 and 7, since whatever we get out for g, we need to make sure it's between 1 and 7 in order to plug it back into the function f of x. So to start, we're going to take the x minus 2, and we know that it needs to be less than or equal to 7 and greater than or equal to 1. From here, we're going to solve it like a normal equation where we add 2, but instead of just adding 2 to two sides, we need to add 2 to all 3 parts of the inequality. So then we will have 3 needs to be less than or equal to x, which needs to be less than or equal to 7. So this may help to draw a number line. So all of the values for f of g of x, we need to make sure are in between 3 and 7. However, we need to keep in mind our restrictions for g of x. And we can plug numbers into g of x that are in between 2 and 6. So you can see what we came up with is that we can plug values in between 3 and 7. However, we can't plug in 2 and we can't plug in 6 because that doesn't work in my new domain for f of g of x. So what we need to do is find what values of x overlap in both of these domains. And so right here you can see that 3 works for f of g of x and works for the original function g of x. Right here, 6 was the maximum value we could plug into g of x right here, and also remains inside of this domain for f of g of x. So right in here is my overlapping region. And so my domain for the composite function f of g of x is that x needs to be less than or equal to 7 and greater than or equal to 3.